do break that field down into 10 by 10 meter grids and assess a potential productivity on each one of those 10 by 10 meter grids. And so that's quite a bit different than what we've done in the past. And you've heard Ted talk about soil type. The grower knows that soil type differences or soil mineralogy differences out there in the field could influence, and probably does influence, the productivity of each acre, but it doesn't completely describe that variability. What I have in this first poster is essentially, we see our GBI image, essentially an aerial imagery taken from that, an airplane, and really assessing that variability in biomass density across essentially this farm. You can see this is the building that we came from. We're approximately right here, or in this particular map, right here. The blue lines and that GBI, now let's say the GBI is draped over topography. The blue lines is your national soil map, or SERGO, and you can see that they are also draped across. If you look at that variability within that soil type as a surrogate on that GBI, really talking about that spatial, the spatial differences in biomass, you can see that soil type alone does not describe that variability. And so when we look at that and start to break that down into 10 by 10 meter grids, we really start to see how that really is defined. So think about it this way. With that topography layer, if you look to the east here, you can see that there is probably a 10 to 15 foot difference in elevation. So if we get a 2-inch rainfall here on this particular farm, and it's high intensity, it'll still land, particularly up there on that upslope area, but we have to predict how much would run essentially to this downslope area and benefit this crop here and not do as much there. And those are the challenges that we have, because if we can produce 10, 15 bushels more down in this downslope area with higher population and really getting to that potential productivity, we need to.